That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives.
It is a wonderful and astonishing thing to me that we are, you and I, are somehow at least one of the ways that the universe knows itself.
Those worlds in space are as countless as all the grains of sand on all the beaches of the earth. Each of those worlds is as real as ours. In every one of them, there's a succession of incidents, events, occurrences, which influence its future.
We are special because we're the same. We are one, not only with each other, but with the universe itself.
I know Hamlet, and what he might say with irony, I say with conviction. What a piece of work is man! How noble it is, how infinite in faculty, in form, in moving, how express and admirable, in action, how like an angel, in apprehension, how like a god.
It is the struggle itself that is most important. We must strive to be more than we are, Law. It does not matter that we will never reach our ultimate goal. The effort yields its own rewards.
Let's go! 12, 11, 10, 9, 8.
Let's
7,
rock and roll!
6.
Why don't you come with me? look inside, girl. Let the sound take you away. Last night I hold her lead land, and so I wish that I could stay. Before the thing could answer me, well, someone came and took the lamp away. I looked around, a lousy candle's all I found. Well, you don't know what we can find. Why don't you come with me, little girl, on a magic carpet ride? Well, you don't know what we can see. Why don't you tell your dreams to me? Fantasy will set you free.
Hello class! So for today, we will continue with our tour of the solar system by visiting the outer planets of the solar system. So are you not excited to visit the outer planets, Jupiter, Saturn, Uranus, Neptune? And we may include in our visit Pluto and some of the other members of the solar system. So come with me and let us now journey to the outer planets of the solar system. But let me first prepare. So I will beam up back to our Starship Enterprise and prepare for our guided tour of the solar system. Alright, so Scotty, beam me up. Energize. Okay. Alright. I'm back in the classroom. Alright, so welcome again class. And for today, we will be visiting the outer planets of the solar system. Our first stop in our journey to the solar system is the mighty Jupiter. Okay, but before we can visit Jupiter, we will have to cross the so-called asteroid belt. Now, the asteroid belt is that region between the orbits of Mars and Jupiter. And this region is composed of small to large irregularly shaped objects called asteroids. Okay, and again, these asteroids are located between Mars and Jupiter. So you will notice that there is a huge gap between Mars and Jupiter. And this huge gap is occupied by those asteroids or those irregularly shaped objects. Okay, so let us now place our starship at impulse power. Let's slow down a bit. And let us now cross the asteroid belt. And at the same time, let's activate our sensors so that we can gather information about the asteroids and the asteroid belt. Now, what are asteroids? Now, asteroids, these are small, irregular shaped objects mostly in the apparent gap between the orbits of Mars and Jupiter. Now, there are thousands of these asteroids located in that gap between Mars and Jupiter. Now, many astronomers believed that asteroids are actually remnants of a planet that broke up some 4.6 billion years ago. So there was a planet in that region between Mars and Jupiter, and for some unknown cause, that planet broke up, and the remains now are the asteroids that we see today. Okay, so here is a picture of some asteroids that orbit the Sun between Mars and Jupiter. So we have the following like Matilde, Gaspra, Eros, Itokawa, and we may include also Phobos and Deimos. Though Phobos and Deimos are Martian moons, many astronomers believe that Phobos and Deimos may have been captured asteroids from the asteroid belt. Okay, so those are the asteroids located in that region between Mars and Jupiter. Now, there are several space probes that have visited the asteroids and the asteroid belt. So they include the following, such as NASA's Galileo mission was the first spacecraft to fly past an asteroid. It flew past the asteroid Gaspara in 1991 and the asteroid Ida in 1993. Then we have NASA's Near-Earth Asteroid Rendezvous or NEAR Shoemaker studied the asteroids Matilde and Eros, and the Rosetta mission encountered Steins in 2008 and Lutitia in 2010. Then we have in 2005 the Japanese spacecraft Hayabusa landed on the near-Earth asteroid Itokawa and attempted to collect samples. Then on June 3 of 2010, Hayabusa successfully returned to Earth, a small amount of asteroid dust now being studied by scientists. And lastly, we have the NASA's Dawn spacecraft. The Dawn spacecraft was launched in 2007 and orbited and explored the asteroid Vesta for over a year. Alright, so this is the Near Shoemaker space probe, and this is Hayabusa that visited the asteroid Itokawa. Okay, so I guess we can now go back to our Starship Enterprise, and let us now travel at warp speed on our way to our next stop on our journey to the solar system. So we shall now visit the mighty Jupiter. Now that's a symbol for Jupiter. The planet was named after the Roman supreme god. The Greek counterpart of Jupiter is Zeus. Okay, so let us now activate our sensors and let us now gather information about the mighty Jupiter. Now, in terms of mass, Jupiter has a mass that is 2.5 times greater than the mass of all the other planets, including their moons combined. That's how massive Jupiter is. The mass of Jupiter is 2.5 times greater than the mass of all the other planets and their moons combined. Okay? Alright, so let us compare now Jupiter with the Earth in terms of its size. So this blue dot is our planet, and this is the mighty Jupiter. Okay, that's why Jupiter is the largest planet in our solar system. Okay, let's talk about now the atmosphere of Jupiter. Now, the atmosphere of Jupiter is composed of the following. So, the atmosphere is composed mostly of hydrogen and helium with traces of methane and ammonia. Okay? Alright, let's take a look at this pie chart showing the composition of the atmosphere of Jupiter. So, the atmosphere of Jupiter is composed mostly of hydrogen at around 89.8%. And you have 10.2% helium. Plus, you have the other gases such as methane and ammonia. Alright, so that's the composition of the atmosphere of Jupiter. Now, there are certain odd features in the atmosphere of Jupiter. Now, one such example is the so-called Great Red Spot. This Great Red Spot has been observed by many astronomers, including Galileo Galilei. Now, when the Voyager space probe visited Jupiter, they found out that this Great Red Spot is actually a giant storm. Alright, so that's the Great Red Spot. And astronomers have discovered that this Great Red Spot is actually a giant cyclonic storm that has been raging the atmosphere of Jupiter. The Great Red Spot is even larger than planet Earth, about 3 times that of the size of planet Earth. Alright, so that's the Great Red Spot, which is a giant storm. Alright, so fantastic, isn't it? Now, if you will look closely at the Great Red Spot, you will notice that the Great Red Spot is rotating in a counterclockwise direction, just like any storm here on Earth. Okay? So that's the Great Red Spot, which is actually a giant cyclonic storm. Okay? Alright, so that's the Great Red Spot of the mighty Jupiter. And you will notice that the atmosphere of Jupiter has a banded or belted appearance. And look at the bands or belts of the atmosphere of Jupiter. The bands or belts are moving in opposite directions. So isn't that fascinating? So the atmosphere of Jupiter has a banded or belted appearance, and these belts or bands are moving in opposite directions. Right? And we have here the famous North Equatorial Belt or the North Equatorial Band, and the South Equatorial Belt or the South Equatorial Band. So those belts, the North and South Equatorial Belts, can be seen even through the telescopes of amateur astronomers. Alright, so those are the belts in the atmosphere of Jupiter. Now, these belts or bands, they are so magnificent when seen through the telescopes of amateur astronomers. Okay, so again, here are the bands or belts in the atmosphere of Jupiter. And again, they move in opposite directions. And we have here the famous Great Red Spot of Jupiter, which is really a cyclonic storm. Okay, so what about now the rotation of Jupiter on its axis? Now, Jupiter is considered the most rapidly rotating planet in the solar system. Its rotation period is slightly less than 10 hours, or about 9 hours and 50 minutes to be exact. That's the rotation period of Jupiter. Jupiter rotates in just 9 hours and 50 minutes at the equator. Now, because of this rapid rotation on its axis, the shape of Jupiter is not really that of a perfect sphere, but the shape of Jupiter is somewhat bulging at the equator and slightly flattened at the poles. So we call this an oblate spheroid. Okay, so that's the shape of Jupiter. because of its rapid rotation. And because of this unusual shape of Jupiter, it means only one thing, that Jupiter has a non-solid surface or a non-solid structure. Okay, so Jupiter is made up of gas. Okay, Jupiter is a gas planet. Now, even though Jupiter is a gas planet, Jupiter was not spared from comets and asteroid bombardments. So one example was the collision of Shoemaker-Levy 9 to Jupiter. Alright, so that encircled part of Jupiter was Shoemaker-Levy 9, which is a comet. This comet collided with the mighty Jupiter. So even the gas planets were not spared from asteroids or comet bombardments. So even the inner planets were not spared, like Mercury. So an asteroid bombarded Mercury that created the Caloris Basin. Alright, Venus was not spared. So a protoplanet or a huge asteroid bombarded Venus, and because of that, the rotation of Venus was shifted from counterclockwise to clockwise. Okay, Earth was not spared also. And there was this asteroid that bombarded the Earth 65 million years ago that wiped out 95% of life on Earth, including the dinosaurs. Right? Mars was not even spared. So there was an asteroid that bombarded Mars that created Hellas Planitia. Right? Jupiter collided with a comet just recently, the so-called Shoemaker-Levy 9. Now, because of the intense gravitational field of Jupiter, many astronomers believe that actually Jupiter protects us from these asteroids and comet bombardments. Now, due to the gravitational field of the mighty Jupiter, Jupiter actually deflects the direction of comets or asteroids that might hit our planet. So let us thank the mighty Jupiter for protecting us from potential asteroids or comet bombardments. Now that's really fascinating about how Jupiter protected us from potential asteroid and comet bombardments. Okay, so let us now study the so-called Galilean moons. Now, these Galilean moons, these are the 4 largest moons of Jupiter as discovered by Galileo Galilei. Now, remember, Jupiter is orbited by more than 64 moons, but these are the 4 largest moons of Jupiter as discovered by Galileo Galilei. So let us now direct our starship and let us now visit those 4 largest moons of Jupiter. And let us now activate our sensors so that we can gather information about those 4 moons of Jupiter. Okay, so these are the 4 largest moons of Jupiter. So we have Io, Europa, Ganymede, and Callisto. So these are the 4 largest moons of Jupiter as discovered by Galileo. So they are the so-called Galilean moons. But again, remember, Jupiter is orbited by more than 64 plus moons. Okay? So these are the 4 largest moons of Jupiter. You have Io, Europa, Ganymede, and Callisto. Alright? So let us now start with Europa. Now, Europa is made up primarily of silicate rock. And what is surprising about Europa is that the surface of Europa is composed of ice that is solid water. And that makes Europa one of the smoothest of the moons in the solar system. The surface of Europa is also striated as seen by Voyager. It is striated by cracked cracks and streaks. This is due to the tidal forces between Europa and Jupiter. Okay, that's why the surface of Europa is striated with cracks and streaks. And this is again due to the tidal forces between Europa and the mighty Jupiter. And again, the surface of Europa is covered with ice. And you know what that means. So ice is solid water, and we know that beneath that solid icy sheet, there is liquid water beneath that icy solid sheet of Europa. And because of that, Europa is a prime candidate for the existence of life beyond planet Earth. In astrobiology, the search for life outside Earth is the search for water. And that's really fascinating about Europa. So beneath that icy covering, there is liquid water under that icy sheet. That makes Europa a good candidate for the existence of life. Again, in astrobiology, the search for life outside planet Earth is the search for water. And NASA is planning to send a space probe on Europa. This space probe will drill a hole through that solid icy sheet of Europa, and once it penetrated that icy sheet, it will send a robotic submarine to explore that liquid ocean underneath that icy sheet of Europa. Now, that is really fascinating about Europa. Okay, our next stop now is Callisto. Now, Callisto is composed of equal amounts of rock and ice. And what is unusual about Callisto is that Callisto is a heavily cratered moon of Jupiter. Now, look closely at this photo taken by the Voyager space probe. And again, you will see that the surface of Callisto is really heavily cratered. Okay? Alright, our next stop now is Io. Now, Io is so unusual because Io has more than 400 active volcanoes on its surface. Io is considered one of the most geologically active objects in the solar system with more than 400 active volcanoes. Okay? And as discovered by Voyager, there are plumes of sulfur dioxide, okay, erupting from those volcanoes on the surface of Io, as you could see in this photo taken by the Voyager space probe. So Io really is geologically active with plumes of sulfur dioxide emanating from its surface. Okay? And the surface of Io is yellow, again because of sulfur dioxide. Alright? Okay, so that's quite fascinating, isn't it? Okay, so these are the plumes of sulfur dioxide erupting from those volcanoes on the surface of Io. Okay, so Io is considered one of the most geologically active objects in the solar system. Okay, and lastly, we have Ganymede. Okay, now Ganymede, just like Callisto, is also heavily cratered, and Ganymede is composed of equal amounts of rock and ice, just like Callisto. Okay, so as you could see, that the surface of Ganymede is heavily cratered. And what is unusual about Ganymede is that Ganymede is the largest moon, not only in Jupiter, but the largest moon in the solar system. So look at this picture taken by Voyager, that the surface of Ganymede is heavily cratered just like Callisto. Now that's Ganymede, the largest moon in the solar system. Okay, so at this point, let us now study the exploration of Jupiter. Now, Jupiter has been visited by Pioneer 10. Pioneer 10 is an American space probe launched in 1972 and completed the first mission to the planet Jupiter. And Pioneer 10 also became the first to achieve the escape velocity needed to leave the solar system. So after its flyby mission to Jupiter, Pioneer 10 left the solar system. Okay, now what is so special about Pioneer 10? Now inside Pioneer 10 is a golden plaque. So something like this, and this plaque was designed by no other than Carl Sagan. Now this plaque contains the following information. So we have here the images of man and woman, and right down here we have here the solar system, and this is a sketch of Pioneer 10, and it shows where Pioneer 10 originated right here in this third rock in the solar system. So this represents planet Earth. Okay, and this is a representation of the hydrogen and helium atoms, and we have here a simple sketch of the Pioneer 10 space probe. So come to think of it, Pioneer 10 is like a message in a bottle. So since it is out in the solar system, who knows, someday intelligent alien life forms may pick up Pioneer 10, and hopefully they can decipher this golden plaque so that they would know who we are. Now, 6 years after the success of Pioneer 10, NASA launched Voyager. There were two Voyager missions, Voyager 1 and Voyager 2. The Voyager missions vastly improved our understanding of the Galilean moons. The Voyager missions was able to take high-resolution images of the planet Jupiter, and the Voyager missions have discovered the rings of Jupiter. So we know now that Jupiter is surrounded by rings. The rings of Jupiter are made of rocky material, probably from the asteroid belt, in contrast to the rings of Saturn, which is made of ice. And the Voyager missions also discovered that the Great Red Spot is actually a giant cyclonic storm. Now that's really fascinating about Voyager. Now there were two Voyager missions sent by NASA, Voyager 1 and Voyager 2. Now Voyager 1 went on a flyby mission to Jupiter and Saturn. Now, after visiting Saturn, Voyager 1 went out of the solar system and is now on its journey into interstellar space, while Voyager 2 continued in its grand tour of the outer planets of the solar system, visiting Saturn, Uranus, and Neptune before leaving the solar system and into interstellar space. Now, what is so unique about the Voyager spacecraft? Now, inside the Voyager spacecraft is a golden record. Now, recorded or stored in that golden record are the images and music of our planet. So that golden record is like a message in a bottle, like Pioneer 10. So we are hoping that some intelligent life may pick up both Voyager spacecraft, Voyager 1 and 2. And hopefully they may decipher the hidden message that is stored in those golden records stored in Voyager 1 and 2. Okay? So we are looking forward that someday that some alien civilization may pick up our message in a bottle. That's Voyagers 1 and 2. Now, isn't that fascinating about Voyager? Okay, so both Voyagers 1 and 2 are now out of the solar system, and they are now on their journey to interstellar space with the golden records, hoping that someday some alien life forms may pick up Voyager 1 and 2. Okay, so Voyager is now out in interstellar space where no man has ever gone before. So class, before we move on to our next stop on our journey to the solar system, which is the magnificent Saturn, let's watch this fascinating video about the mighty Jupiter. So let's watch this.
Jupiter is the fifth planet from the Sun and the largest planet in the solar system. At approximately 11 Earths wide, Jupiter has twice the amount of mass as the other planets put together. But unlike Earth and the 3 other terrestrial worlds, Jupiter has no solid surface. It may not even have a traditionally solid core. Rather, this giant planet may have a dense liquid center surrounded by a worldwide ocean of hydrogen and helium gases. Jupiter's gaseous composition can be observed in its atmosphere. About 44 miles thick, the atmosphere is a canvas of stripes and storms churning across the giant planet. Their colors range between shades of whites, yellows, browns, and reds, all caused by the different chemical makeup of each area. Probably the most iconic feature of Jupiter is a crimson-brown storm that's been raging for over 300 years, the Great Red Spot. It's a giant swirling collection of clouds with wind speeds of up to 400 miles per hour, at least 2.5 times faster than Category 5 hurricanes. Floating hundreds of miles above the storms of Jupiter are about 79 moons, the most of the 8 known planets. The 4 largest moons were discovered by Galileo in 1610. Called the Galilean satellites, they include Io, the most volcanically active celestial body in the solar system, Ganymede, the solar system's largest moon, even larger than the planet Mercury, and Callisto and Europa, which, along with Ganymede, may contain oceans of liquid water underneath their crusts. Jupiter's large collection of moons is only made possible by the planet's massive size and gravitational pull, the strongest of all the planets in the solar system. This incredible gravity also influenced the sizes of the 7 other planets. During the solar system's earliest days, Jupiter, being the first planet to form, attracted and destroyed space debris that would have helped the other planets grow in size. Today, that force may serve as a shield by attracting comets and asteroids onto Jupiter's own surface, preventing them from crashing onto inner planets like Earth. Apart from the Sun, Jupiter has become the dominant figure in the solar system, thereby earning its place at the top of the planetary heap as king.
Okay, so I guess that's it for Jupiter. So let us now beam back to our starship and let us now travel at warp speed on our way to the next stop in our journey to the solar system. So we shall now visit the planet Saturn. So that's the symbol for Saturn. Saturn was named after the Roman god of agriculture. So let us place now our starship in parking orbit around Saturn. And let us now activate our sensors so that we can gather data about this magnificent ringed planet. Now, Saturn revolves around the Sun at an average distance of about 1.4 billion kilometers. The atmosphere of Saturn is very similar to Jupiter, with hydrogen and helium as the most abundant gases, with traces of methane and ammonia. And in terms of the density of the planet, Saturn has the lowest density of any planet in the solar system. In fact, if you will allow Saturn to float on a gargantuan sea, Saturn will really float because of its very low density. Now, let's compare the size of Saturn with that of planet Earth. Now, looking at this photo, it is quite obvious that Saturn is the second largest planet in the solar system. Okay, but in spite of its size, Saturn has the lowest density of all the planets in the solar system. Now, in terms of its rotation on its axis and its revolution around the Sun, Saturn has the second shortest day in the solar system. So, one day on Saturn takes only about 10.7 hours. Jupiter is still the fastest. Then second is Saturn. So one day in Saturn is only 10 hours and 7 minutes. Okay? And in terms of its revolution around the Sun, Saturn makes a complete orbit around the Sun in about 29.4 Earth years. Okay, so that's the rotation of Saturn on its axis and its revolution around the Sun. Now, going back to the atmosphere of Saturn, the atmosphere of Saturn exhibits a banded or belted appearance which is similar to Jupiter. But the atmospheric belts or atmospheric bands of Saturn are much fainter and wider near the equator. And the atmosphere of Saturn is quite violent and active with high-speed winds of about 1,500 kilometers per hour. So isn't that fascinating about the atmosphere of Saturn? Okay, so what about the rings of Saturn? Now, the rings of Saturn are made of particles of ice, ranging in size from a grain of sand to the size of an automobile. And since the rings are made of ice, the rings of Saturn is highly reflective in contrast to the rings of Jupiter, which is made up of rocky material. Okay? And many astronomers believe that the rings of Saturn are the remnants of a destroyed moon of Saturn. Okay, so you can just imagine if our own moon explodes or if our own moon is destroyed, then the remnants of our own moon would encircle the Earth, forming rings. So just like Saturn, so many astronomers believe that the rings of Saturn are the remnants of a destroyed moon of Saturn. And the rings of Saturn again are made up of ice particles ranging from grains of sand to the size of automobiles. So these ice particles, they are like tiny moons orbiting Saturn. Okay? And there are times that the rings of Saturn is tilted or angled as seen through Earth-based telescopes. As you could see in this animated illustration, that year after year from 2012 to 2015, the planet, including the rings, gets tilted. And that's really amazing. This is seen by amateur astronomers using their Earth-based telescopes. Okay, now Giovanni Cassini, if you will recall, Giovanni Cassini discovered a huge gap between the A ring and the B ring of Saturn. This huge gap is known as the Cassini division, named after him. So the Cassini division is that gap between the A ring and the B ring of Saturn. Okay? So that's the Cassini division. This is seen easily even through Earth-based telescopes. Okay. So that's the rings of Saturn and the Cassini division. Alright, let's talk about now the moons of Saturn. Now, Saturn is orbited by many moons, just like Jupiter. The largest moon of Saturn is Titan. Okay, so that's Titan. And Titan is the only moon in the solar system that has a dense atmosphere. Okay, Titan is the largest moon of Saturn, and Titan is the only moon in the solar system that has a dense atmosphere. And you will be surprised that the atmosphere of Titan is composed mostly of nitrogen, which is similar to Earth. The Earth's atmosphere is composed mostly of nitrogen, about 71%, and 21% oxygen. The atmosphere of Titan is composed mainly of nitrogen. So Titan is a candidate for the existence of life outside planet Earth. Now, let's compare Titan with that of our moon in terms of size. Now, it's obvious that Titan is much bigger than our own moon, and Titan is still much bigger than Triton. Triton is the largest moon of Neptune. So Titan is the only moon in the solar system that has a dense atmosphere composed mostly of nitrogen, very similar to Earth. And Titan has been visited by the Huygens space probe. The Huygens space probe successfully landed on Titan, and the Huygens probe discovered lakes of methane. So that makes Titan a pretty good candidate for the existence of life, because maybe on those methane lakes, extremophiles, specifically methanogens, may exist. Just like here on Earth. Here on Earth, we have microorganisms called methanogens that can tolerate high concentrations of methane. So most probably, if we would send another mission to Titan, hopefully we can discover those extremophiles or microorganisms that can tolerate high concentrations of methane. Okay, now what about the exploration of Saturn? Now, Saturn has been visited by Pioneer 11. Pioneer 11 carried out the first flyby mission to Saturn in September of 1979. Then it passed within 20,000 kilometers of the planet's cloud tops, and images were taken of the planet and few of its moons. So that's Pioneer 11. Then in November of 1980, Saturn was visited by Voyager 1. Voyager 1 took high-resolution images of Saturn, its rings, and its satellites. And after that flyby mission, Voyager 1 went out of the solar system, and it is now in interstellar space. Okay? Then Saturn has been visited in July of 2004 by the CASSINI-HUYGENS space probe. The CASSINI-HUYGENS space probe performed the SOI, or Saturn Orbit Insertion. So the spacecraft entered into orbit around Saturn. Okay, so this is the CASSINI-HUYGENS probe. The CASSINI-HUYGENS mission is actually made up of two spacecraft. So we have the Cassini and the Huygens probe. The Huygens probe landed on Titan. Okay, so that's the Cassini-Huygens space probe. Alright, so I guess that's about it for our visit to Saturn. So let us go back to our starship, and let us now move to our next stop in our journey through the solar system. Okay, class. So before we proceed to our next stop on our journey to the solar system, which is the planet Uranus, let's watch this fascinating video about Saturn and its rings and its moons. So let's watch this.
Saturn is the second largest of the 8 planets, and it is about 10 times as wide as Earth. Despite its size, Saturn is actually the lightest planet. It is predominantly made of the gases hydrogen and helium, and because of its particular gaseous composition, Saturn is the only planet in the solar system that's less dense than water. If the planet were placed on an enormous ocean, it would be able to float. Saturn's gaseous makeup also means that it has no true surface. At its center, the planet has a dense core of water, ice, and rocky material, but it has no actual landmass. Instead, it's mostly made of gases, liquids, and yellow ammonia crystals that swirl around the planet, creating golden clouds and storms. The largest storm on Saturn is at its North Pole. It's over twice the size of Earth and shaped in a near-perfect hexagon. Each of the 6 sides is believed to be the result of jet streams, which all encircle a massive hurricane. Because of Saturn's inhospitable environment, the planet cannot support life, but some of its moons might. Saturn has more than 50 confirmed moons, and each varies in size and terrain. Enceladus, one of Saturn's smallest moons, is covered in ice and only about as wide as the state of Pennsylvania. Titan, Saturn's largest moon, is nearly as wide as Canada. Titan is also the only moon in the solar system with clouds and a dense atmosphere. Both Titan and Enceladus have underground oceans that would make them potentially capable of sustaining life. Saturn's moons may also play a role in shaping the planet's signature feature, its rings. Saturn's ring system is the largest and most complex in the entire solar system. The rings are made of icy and rocky remnants from comets, asteroids, and moons. The particles range in size from being as small as dust to as big as mountains. The ring system is divided into 7 groups of rings. Altogether, they are as wide as 4.5 Earths, but only about 2/3 of a mile thick. How the rings are able to stay on track and intact has to do with Saturn's smallest moons. Called shepherding moons, these tiny satellites orbit between the rings, and they seem to use their gravity to shape the ring material into circular paths. Saturn has fascinated scientists and amateur astronomers alike for thousands of years. The ancient Greeks and Romans, who named the planet after their god of agriculture, believed it was a star. It wasn't until the 17th century, after the telescope was invented, that scientists like Galileo Galilei, CASSINI-HUYGENS, and Giovanni Cassini could take a much closer look. Only then was Saturn's planetary status discovered, and ultimately, its many moons and brilliant rings. Because of its planet-like moons, lightweight composition, and dazzling ring system, Saturn continues to...
That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives.
It is a wonderful and astonishing thing to me that we are, you and I, are somehow at least one of the ways that the universe knows itself.
Those worlds in space are as countless as all the grains of sand and all the beaches of the earth. Each of those worlds is as real as ours. In every one of them, there's a succession of incidents, events, occurrences, which influence its future.
We are special because we're the same. We are one, not only with each other, but with the universe itself.
know Hamlet. And what he might say with irony, I say with conviction. What a piece of work is man. How noble it is, how infinite in faculty, in form, in moving, how express and admirable, in action, how like an angel, in apprehension, how like a god.
It is the struggle itself that is most important. We must strive to be more than we are, Law. It does not matter that we will never reach our ultimate goal. The effort yields its own rewards.
Ten, 9, 8.
Let's
7,
rock and roll!
6.
On the cloud of sound, I looked in the night. Any place that goes is right. Goes far, flies near, goes stars away from here. Well, you don't know what we can find. Why don't you come with me, little girl, on a magic carpet ride? You don't know what we can see. Why don't you tell your dreams to me? Fantasy will set you free. Close your eyes, girl. Look inside, girl. Let the sound take you away.